All right, let me get a full screen here. It could be the last video I make. I don't know. I'm retiring. I put Rennie the cart out to pasture, and I think I'm headed there myself. If I find a local library or something, maybe might continue with some lesson sets from pre-cal up through calc. I think the first 1 through 50 lesson sets. If you're out there and you get a chance to work through those, I think you can probably get through those in 50 days and have a fairly decent Algebra 1 and Algebra 2 foundation and some intro to trig. And if I continue, maybe I'll make another 50 lesson sets through trig and some more pre-calculus concepts or topics and then jump into calc. But I've enjoyed doing this over the last few years, and I've enjoyed hearing from folks, different comments, and not looking for subscriptions or anything, just putting this stuff out there for people to consider and hopefully get a chance to move up the ladder in this discipline. I've got 2 challenge questions here and thought it'd be a nice way to end. So I put them out there. The nice thing about mathematics is you own your writing utensil. Right? You get to write what you want. The only thing is you just want to make sure that whatever statement you make is equal to whatever you're talking about. Okay, whether it's simplification or constructing some algorithms. All right, so these are typical log and, well, not typical logs and exponentials, but they're challenges, but they do follow the same kind of format, thought process that are in the speed graphing of exponentials and logs and that whole process. So I just put them out there, see if you can do them. I like to think about this one as pizza in the oven. So 5 minutes from now, pizza's 31 degrees. I don't know anything about the physics of pizza coming out of the freezer, but you've got one. And so 5 minutes from now, we're going to put it in the oven and the pizza's 31 degrees. 16 minutes. At the 16-minute mark, it's 3:01. I don't know how long it takes to cook a pizza. I assume it's about 15 minutes. So the oven's 350. So see if you can write that. All right. And I'm suggesting that you can write these as quickly as you write the equation of a line once you understand the conversion process. Let's hope I do it properly because I just threw these numbers up. Don't have Rennie the card, so I'm going to have to move the computer to the other one in a second. And this is what I see. I see y equals, although I think we'd be better off if we said equals y, then the brain would be left to right oriented. But we have y equals, and I see a y, I see 31, but I'm measuring from 350. So the question is, how do I get from 350 degrees to 31 degrees? And I think it's subtracting 319 and been out in the sun, got a little sunburn, and hopefully I'm computing things properly. So yeah, that seems right. And then the next time, it's not 319 degrees as a differential, right? It's still following that differential to the next differential. How do I get from 350 to 301? Looks like I got to go down 49. And so these would both be negative perhaps, but this takes care of that. And we want to start with b to the 0 equals 1 and b to the 1 equals b. That simple knowledge allows us to say t minus 5. So we have temperature as a function of time. And maybe I should go x since I wrote y over here. So I got x minus 5. So you drop the 5 in, that's a 0. That makes that 1. Take 319 away from 350. You got that temp. And then if we drop a 16 in, we can see 11 minutes have, 16 minus 5, 11 minutes have elapsed. And 11 divided by 11 is 1. The 319s cancel. And 350 minus 49 is 301. So I think that's right. Hope so. Let's come over here and let's take a look at this logarithm. And we'll look at the differentials a little bit and put some new numbers in to show you a little bit more about the pattern there. All right, so we're measuring from x equals 4. So this is going to be, I'll pause the video, right? You pause the video, think about it as long as you want, take a month, whatever. Just come up with the right answer and then you're not studying mathematics, you're being a mathematician. All right, so let's start with y equals. I see, what do I see? I see 20. And then I got to get to 43, so I guess I'm going up 23. Sure looks like a logarithm, so write that in. What's different here? Well, we're measuring from 4, but we're not measuring to the right. We're measuring to the left. That's a change of direction. So instead of writing x minus 4, I'm going to write 4 minus x. Now when I drop a -1, minus a -1, up, +1, 4. So I'll divide by 5. 4 plus 1 is 5. But 5 divided by 5 is 1. And I don't care what the base is. Log 1 gets you 0. 0 times anything is 0. Bingo, you got 20. Now when we drop -11 in, we get 15 over 5, which is a base 3 logarithm. And now put -11 in, 15 over 5 gives me the 3's. And so if I got a 3 in here in the argument, the base 3, then that's the number 1. So one jump of 23 from 20 takes me to 43. And I think we've established a 1 to 3 ratio, which means the next number that's friendly is going to be 9, going to be the same jump, although I didn't draw it too well, be a little higher up, right? And that's 9 units. 9 to 3 is still a base 3 differential. But remember, the first differential from 4 to -1 was actually 5 units. So that should be 15 units. And then this should be 45 units. So what's my next friendly number? My next friendly number is 45 from 4. I guess I'm at -41. Is that right? Well, let's put it in and find out. Minus a minus 41, 41 plus 4, 45 divided by 5. Yep, 9. What's the exponent you put on top of the 3 to get a 9? 2 jumps of 23, so you went up 23 once. You went up 23 again. And each time you're, the inverse of exponential growth here. Reversed, kind of reflection, right? Sort of. I don't know what the language might be, but anyway, just a little practice, just a little mathematical practice, and you can replay the video a few times, maybe in 4 days, 2 minutes today, 2 minutes tomorrow, 2 minutes, so on and so forth. Usually after 4 days of a couple of minutes of consideration, there's some real understanding that takes place. Let your brain go through that process, and then practice a few more times, and maybe then every other week, and keep it in front of you, and might own it until you go into the next class, because this stuff's only good if you recall it as you go up the ladder. All right, so that's that, signing off. I'll get a new email, see if I can transfer my account to a new computer. New computer is going to give me trouble. I'm of that generation, but we'll see what happens if I come back online. If not, thanks for the comments. Appreciate it, and good luck with your studies. All right, all done. Yeah. And I guess that'll be it.